So I will explain once again. Okay, so in case of port 2 or port 0, as I have mentioned earlier, if we want to use the port 0 or port 2 as an IO port, in that case you should make control signal is equal to 0. And if we want to use port 2 or port 0, any one of them, as a alternate pin function. Alternate pin function means in case of port 0, the alternate pin function provided for port 0 are either used as address bus, that is lower order A0 to A7, or data bus D0 to D7. In case of data bus, we cannot say the lower order data bus because the data bus available with 8051 is having only capacity of 8 bits. So D0 to D7 is the only single data bus, that is 8 bits available in port 0. So we cannot say lower order data bus. If it is 16-bit data bus, then we may say lower order, higher order. But in case of only 8 bits, we cannot say the lower order. So address bus is having capacity of 16-bit. That's why we may say lower order or higher order address bus. So A0 to A7 lower order address bus, and A8 to A15 higher order address bus. Here in case of port 2, alternate pin function is higher order address bus, that is A8 to A15. And if we move towards the first application of an port 2, that is IO port, I/I/O port, and that too first condition is that working as a input port. So while use as a port or port pin input, in that case you should make internal bus 1 or high. So in this diagram, if we make internal bus is high, that is 1, Q becomes 1, and here from the mux side, if control signal is 0, that is moving in this direction, left hand side. If we want to draw, in that case you should draw here 0 and here 1, this side address line side, say write 1. So if we want to use as an input port and 1 is applied, so this 1 is transferred as an input to the NOT gate. So whatever signal is there, it will be delivered to the NOT gate as an input. So when we apply 1, as it is here, 1 is written, as it is 1 is written at the internal bus, which will be transferred to the input of an NOT gate, and after the input, so output of a NOT gate becomes 0. So your lower FET turns off. Here lower FET does not turn on because 0 is applied. Okay, so here it is in off state, and similar to port 1, port 2 is also associated with internal pull-up register, but this resistance may decreases when we make that signal high or connected to this. Here control signal is 0, that's why output of AND gate becomes 0. So resistor switching condition, minimizing the resistance, is not done. So whatever the initial resistance is there at pull-up register, it will remain same. And here it is in open state. And at the same time, when we want to use a port pin as an input pin, in that case you should activate the tri-state buffer, that is input buffer, and whatever signal is available at port pin, here it is not possible to moving towards ground side, or ground signal is not connected. Here again, after VCC, internal pull-up is there with the having their maximum resistance or fixed resistance value without changing the value. So it will follow the low resistance path in this direction, and here signal is activated, buffer is activated, so it will move towards the internal buffer. So whatever signal is there, either 0, either 1, it will moving in bottom line side and towards the internal bus, that is CPU side. So port 2 acts as an input port by making or turn off your lower FET. Here NOT gate is used. You keep in mind, NOT gate is used. That's why when we apply 1, in that case it will becomes 0. Okay. So here is the condition for input. After that we will go for the output. Similar to earlier ports, when we use a particular port or port pin as an output port, two conditions need to be analyzed. First one is write 0 and second one is write 1. So whenever a CPU side wants to deliver a logic 0 on output pin here, in that case your internal bus needs to be write 0. That is, this signal is coming from CPU side, accumulator or CPU side. So 0 is coming at the internal bus. That 0 is converted here as a flip-flop, that is Q is equal to 0, and same signal is applied as an input to the NOT gate. So when we apply 0 to the NOT gate, it will convert it into the 1 and your lower FET turns on. If your lower FET turns on, it will short circuited ground with the port pin and 0 volt is moving in outward direction like this. So 0 is applied at the port pin as an output signal. So when we apply 0, it will automatically reaches, or signal available on port pin is 0 due to turn on condition of a lower FET. Okay, and if we want to write 1, so first analyze the 0 condition. For 0, Q is equal to 0, applied input to NOT gate is 0, output of NOT gate is 1. Due to this your lower FET turns on and then it will be delivered 0 volt towards the port pin. Okay, so this is related to the writing 0 on port pin of an port 2. After that we will see the writing 1. Okay, so in this case whatever the signal we want to deliver needs to be applied again at internal bus. So for writing 1 we should apply 1 at the internal bus or CPU bus. So this one will be delivered here, again Q is equal to 1, and applied at the input to the NOT gate. So output of NOT gate is 0. Sorry, output of NOT gate is 0. That's why your lower FET turns off. Lower FET turns off, and here also tri-state buffer is also deactivated. So no chance to flow signal in this direction. No. Okay. So this path is also closed. Lower FET is also closed. So whatever signal available after VCC, either in degraded format, but not to it will consider the 0. But whatever signal is available after internal pull-up, this signal will be delivered towards the port pin as a high signal. So by considering 3 volt to 5 volt as a high signal. So selection of internal pull-up. So it is not necessary that we have to select the internal pull-up resistance value. It will be selected automatically or while manufacturing in the architecture itself. But here whatever the signal is generated after the pull-up register, this signal is simply applied or available for the port pin as an output, and that to logic high, that is logic 1. We consider that logic high signal is applied because this path, that is read signal, is closed and also ground signal is also at open circuited. So only one path is available. Whatever signal is available after pull-up, so it will be simply applied in this manner. Okay, upper real section. So this is related to the output section. So after basic operation of port 2, that is I/O operation, we have to use or study the working of port 2 as an address bus. So as we have already said that we have to make control signal is equal to 1 for accessing port 2 as an address bus, and that to higher order address bus. And if on address bus, if the signal available is 0, so if you consider here address bus, signal available is 0 and we want to transfer 0. If it is 0 and control signal is 1, and here switching is at this line only. Okay, so 0 is applied to the NOT gate, and this 0 becomes 1 as output of a NOT gate, and it will turn on the your lower FET. So when 0 is there, your lower FET turns on and it will provide the 0 signal. That is for retrieving address. This address is nothing but we mentioned the address 30H, address 100H, address 2000H. So these 2000, that is 2000 or 0030, 0020, these addresses are mentioned by individual pins. That is 0 is at one pin, next 0 is at next pin, again for that 3, whatever. So whatever the combinations are there, if we are considering hex value, so whatever the equivalent binary value, so for 00, these two numbers are there in hex, so appropriate 8 numbers will be generated in a binary format. That is first 0 40, next 0 40. If we consider the 0 1, in that case 0 at MSB side and 1 is at LSB side, so lower 4 bits of the hex value 1, that is 0001 at the lower nibble as an address bus, and here 0, next 0 is nothing but 4 zeros. Similarly, address or numbers are calculated, and for each pin, that is 8 pins are there now for port 2 or port 0. So according to that, from 0.0 or P 2.0, LSB side is there and MSB side is at 2.7. So according to that, 8-bit numbers are calculated in binary format and signals are applied. Like if we want here 0, in that case your lower FET turns on and it will deliver the 0. Second case, we are not talking about output, we are talking about this address bus. Okay, so circuit is here, and if we want to 1, in that case 1 is applied at the input of NOT gate, and due to this your lower FET turns off because output of NOT gate is 0. So lower FET turns off. Here read is again closed, not available, that is it is deactivated here, so signal doesn't move in this direction. So whatever signal is available after VCC, that is after internal pull-up register, it will be considered or applied to the port, and it will be considered as a high, and that to consider as a 1 for accessing address 1. So while using address bus here, use as a address bus A8 to A15, we should make control signal 1. So control signal is marked as a 1. So due to this, here switching is done in this direction. So switching is this and this direction. So this middle L section forms. Okay, and due to this, if 0 is there, it will turn on the FET. If 1 is there, it will turn off the FET, and according to that, signal is transferred. If 0 is there, that is if 0 is there, it will turn on, if 0 is there, it will turn on the FET and 0 is delivered. If 1 is there, it will turn off the FET, and whatever the signal after internal pull-up, it will be delivered to the port pin and considered as a logic 1. So this is regarding the working of an port 2 as an address bus. So if you have any doubt, please let me know. Hello, are you able to understand the switching between this middle section, control section, that is either IO or control, that is address or data address, whatever. For I am talking about port 0 as well as port 2. Function is similar. Switching is need to be done for use as a IO or use as a address or address data bus. Here we simply say that the bus. Okay. So if it is clear, we will move towards the next.